use it one time, then we store it in it. So the next time the function is called for the same n, we get it from the array. And this is the basic idea of dynamic programming. Is it clear? Okay. Let's move to the next problem. Mhm. Okay. Let's try on this. So we have an n by n grid whose squares may have traps. Okay. It's not allowed to move to a square with a trap, of course. Your task is to calculate the number of paths from the upper left square to the lower right square. You can only move right or down. Okay. So let's look at this for any point on the grid. So the way to arrive to A is either to come from the top or from the left. Okay. So the number of paths to go to A is the number of paths to go to here plus the number of paths to go to here. And if this is a trap, then the number of paths to go to here is obviously 0. So if we have a point with coordinate xy, then f of xy is equal to f of x minus 1, sorry, y, plus f of x y minus 1. And if this point is a trap, then it's obviously equal to 0. Did everyone get the idea? Oh yes, I forgot to send the solve of this, of course. Okay. Let's try to solve this. So we've got this formula. Now we code it. So the input is n, then the map. So and then we have a character double array of dimensions n by n. Not sorry, I can't do this like this. Okay. IJ, okay. Okay, what are the bounds? We put the values here so that we can access them from our functions. So until this. Okay, so for me. And we put another array. int dp. Okay. Does it ask for some modulo? Yes. Okay. Then we apply our formula. So, but before we fill it with minus ones, of course. And dp ij is equal to -1. I and this is also an integer. If map x, y is equal to this character, then it's a strap, so we return 0. Also, from this, there is only one way to go to it. So we put that dp of 0, 0 is equal to one path. If x is less than 1, sorry, less than 0, or y is less than 0, then we return that there is no path also, because it would be one of the boundaries which don't have a path to go to. Then if dp of xy is not -1, then we return it. Else, this is equal to f of x minus 1 y plus f of x y minus 1. Okay, then we return it. Hence the answer is f of n minus 1 n minus 1 and when trying on our example, it gives us the good answer. Let's submit the code. Okay, we got wrong
اسمع
answer
رؤوف،
somewhere.
ارجع لي الكود.
Yep. I forgot
نسيت في
modulo, I guess.
موديلو.
Yep.
يا
Makes sense. Node. Okay. Okay, I guess that's the problem. So let's retry. And now it's working. Did everyone get the solution? Okay, this is for the second problem. Let's move on. Okay, so consider a money system consisting of n coins. Each coin has a positive integer value. Your task is to calculate the number of distinct ways you can produce money sum x using the available coins. Okay. Mhm.
I think a tree would be useful in this case.
A tree.
Yes. I have one. I mean, when I solved this problem, I made a tree, so I can send it if you want.
Just explain me the solve.
What?
You know, I guess this is the problem I explained before. Wait. No. Explain your soul.
Okay, so I'm gonna explain with an example. Say we have nine, and our
Yes.
coins are five, three, and two. To get
Yes.
the total number of ways, we subtract five from nine, we get four, and we solve for that. So we subtract three and two from it. We get two and one, I guess. Then one we can subtract anything from it, so we take it away. And we get two, we can subtract two from two, and we get zero. So this is a way. If we
Okay.
subtract three from nine, we get six. We can
Mm-hmm.
subtract three or two from six. If we subtract three, we get three. We can subtract three again, we get zero. So that's the second way. And we can do this for all combinations, I guess. I'll send you a screenshot.
Okay.
I sent it on the server.
Okay. Let me check it. Green team channel. Okay. So. Mm-hmm.
And I removed all the ones that are incorrect, like subtracting three from four, which wouldn't yield nine in the end, because there's no coin with value one. I only kept the solutions. And then you sum them up, you get one, two, three, four, five, six, seven, eight, I guess.
Yeah, it works.
So simply, we iterate through the coins and subtract the coins from
Okay.
the sum we want, and then solve for that. So we use recursion.
So
Or
here
we
we
can
just
start
notice
from
that.
one and build up. What do you say?
Okay. So just from your tree, we notice that it's just the number of ways to make 4 or 6 or 7, right? And we sum them.
Yeah,
Okay. So if our coins are C1, C2 until Cn, then f of x is f of x minus C1 plus f of x minus C2 until f of x minus Cn, right?
yes.
Okay, great. Let's try it. So, and of course, we apply again memoization so we avoid wasting time in our solution. Okay, so we have an integer n and an array of coins of length n, of course. And yes, we can't use it. So what's the upper bound for n? No, not this. Okay, it's 100. Okay, and intdp, what's the upper bound of x? It's 10 to the power of 6. Okay, perfect. Okay, we also have that dp of 0 is 1, because there is exactly one way to have x equals 0. Then we get n. And we get the values of our coins. So I. Then, and of course, we fill this with minus ones. So if x is negative, we return 0. If dp of x is different of -1, we return dp of x. Else dp of x gets 0, and we add f of x minus c1 minus c2 and c to the end. So for t equals 0, I less than n, I plus plus, dp of x plus equal f of x minus points I. Return dp of x. I guess this is good. And did it ask for some modulo? Yes. So here, dp of x mod equal mod. Okay, let's try on this input. Oh, we input n, then x, then this. Okay, I made a little mistake. Okay, and I have to define x here. And of course, we output f of x. Okay, let's try. Okay, good answer. Let's submit the code. Time limit exceeded. How? Let's try on some test case and see what's wrong. No, it just takes too much time. Okay. Let's reduce the number of operations and just do this. May work. Yeah, it will work for sure. If I change this into okay, let's try with this. And now it goes accepted. Any question? Well, I guess this is enough for dynamic programming. Does anyone want to understand something? Like, yes, we will send them. I will send you more this afternoon, of course. Does anyone have a question in general, not about dynamic programming or something?
I want to ask about mathematical proof. You said that induction is something I need a lot,
Yes.
and I don't know how, because how can I use induction in programming problems?
Mm, let me remember one problem. Wait. I remember a problem from GPOI. Wait. Why isn't my login here? Anyway. I guess it's this. Okay. So we have a problem that can be solved by dynamic programming in O of n, but has a mathematical sequence that have a closed formula, so we can solve it in O of 1. So here we have a bunny has to pass n meters with jumps of length 3, 2, or 1 meters. In how many different ways can this can be done if the length of successive jumps are form a non-increasing sequence? Okay, so it's either decreasing or non-decreasing. Okay, I see. So we can also suppose that it's increasing. It's the same as long as it's monotonic. So let's look at the problem. For n is equal to 7, for example, 7 is either equal to 7 ones okay, or this. Anyway, so we have many ones, and there is how do you say, an inductive formula for this. So as I said before, it's more like the first problem we tried in. So we have f1 of 7 of n. Okay, so this is the max value of a jump. Okay, and f2 of n is equal to okay. Thing is that we can notice that this is, well, this formula is obvious. Then we get that this is always f1 of n minus 2, which is equal to f1 of n minus 1 to 1, which is 1. Okay. So then we replace it here. So we get that f2 of n is equal to 1 plus f2 of n minus 2, okay? Hence, we get that, look, f2 of 1 is equal to 0. f2 of 2 is equal to 1. No, it's equal to 2. Wait. 2, 1 plus 1. Yeah. Okay, this is 1 and this is 2. Okay. Then f2 of 3 is this plus 1. So it's 2. Okay. Then we continue. f2 of 4 is equal to this plus 1 is equal to 3. So we get that here for the function f2, we get for 0, 1, 2, 3, 4, 5, 6, 7. This formula 0, 0, 1, 1, 2, 2, which implies we can prove it by induction, but we get from this that f2 of n is the floor of n over 2. Okay. So it follows that this is equal to n over 2 plus f3 of n minus 3. Okay. And then we find that this is equal to n over 2 until we arrive to either 2, 1 or 0 over 2. And it looks like this is, in fact, sorry, not a geometrical, an arithmetic sequence that we can prove by induction, for example. So here we find the closed formula for f3 of n instead of doing the dynamic programming, which will help us a lot in gaining time when the problem is just a subproblem of another problem, and with that we get a time limit exceeded. Okay? Like the main idea is to find a closed formula for a function instead of computing it recursively. So we get the formula in O of 1 instead of O of n of O of log n or something like that. Okay? Any other questions? By the way, this problem was in the AFPCTSC of February, where someone found the formula for that. I guess Kian and Shamsu. I don't remember well. Oh, he disappeared as always. Any other question? Okay, so yes.
No, no, sorry. I did
Okay.
it by mistake.
Any questions? Okay, so I guess this is enough for today. I will send you a bunch of problems to try and if you're stuck, ask for a hint. And that's all.